Hey class, I wanted to make just a quick video here giving you guys a few hints about tension, as I think a lot of people have had questions on here. The key to understanding tension is that it's always pulling on any object that it's in contact with. So like, for example, if we were to make like a free body diagram for right here where this person's holding the rope, the free body diagram for the point of the hands contacting the rope is you'd have the tension pulling up and the person's pull force pulling down. Those would be equal and opposite. If I were then instead to make a free body diagram, let's say for this pulley, okay, what that pulley would be experiencing, if this is the free body diagram, is there'd actually be a tension pulling to the left from the rope on this side, and a tension also pulling down from the rope on this side, and then the support system would have some net force that's probably going to have to be in this direction. It's almost like a normal force from the pin in the middle of the pulley. Similarly, this one would look very similar to the one I just made. And then lastly, when you get down here, let's maybe try a different color actually. If you get down here to the piano, right, and you're drawing a free body diagram at this location, what the piano's pulley is going to have, again, is you're going to have being pulled down here is the weight of the piano, and then being pulled up is again the tension force, but now it's pulling up two different times, one on each side. So if you notice, you pull down to generate the tension, and it pulls up on the piano two different times. And so that's what we call mechanical advantage and why pulleys are so powerful. So moving quickly over to this other question from the workshop here, where we have these hanging apples, right? If you were to pick any one of these, let's say we just picked B, for example. If we wanted to draw a free body diagram for B, a free body diagram is really freeing that body from everything around it. So if I were to draw just like a little squiggle around B, I only want to worry about what's inside of that squiggle. Some of you want to include D or C or the rope attached to the wall, but those things are not actually in contact with or interacting with B. The only things interacting with B are the rope T1, the rope T2, and then the Earth's pull of gravity is also affecting B. So in my free body diagram, all I would have is T1 going up, T2 going down, and then the weight force of only block B, or apple B, pulling down on it, because those are the only things affecting that apple, right? So if you come down here to D, then all it would have is T3 going up, and then pulling down would just be the weight of block D, okay, or apple D. So keep that in mind as you go forward. And then the last thing I just want to clarify that I've heard from a few people, when we're using Newton's second law and we're doing sum of the forces equals mass times acceleration. Let's say, for example, we're doing this for just the simple case of apple D. The sum of the forces in the y direction, if we call this y and this x here, the sum of the forces in the y is the adding up of the forces actually acting on it. So that's T3 plus the weight, which is down, so minus the weight, which is mass times gravity, equals 0. Its acceleration is 0 because it's held stationary. I've been seeing a lot of people wanting to put g in over here for the acceleration, or getting confused why g is here if the acceleration is 0. Keep in mind, this acceleration right here is always the overall net acceleration of your object. If it's moving and accelerating as a result of that motion, that value would go here. This value, g here, is the universal constant, well, not universal, excuse me, the constant for the surface of Earth of 9.8 meters per second squared. And so this is just used to quantify a set force that is always based on that constant value of 9.8 meters per second squared, and that's the force due to gravity. So this is one single force, where this is the MA, the overall result of all forces acting on it. So here, this A, again, is going to be based on the overall motion, and this will always be 9.8 when calculating the weight of an object. Anyway, hope that helps, give you a few pro tips about tension, and yeah, see you all in class.